How can an entire city made of stone and brick stand on what is essentially a swamp? At first glance, Venice seems to defy the laws of engineering. The city is built in the middle of a lagoon, surrounded by salt water and resting on soft layers of mud and clay. Yet for more than 1,000 years, its magnificent churches, palaces, and bridges have remained standing despite floods, tides, and constant ground movement. The story begins in 452 AD, when people fleeing the barbarian invasions sought refuge on the muddy islands of the Venetian lagoon. What started as a temporary shelter soon grew into one of the greatest maritime powers in history. But before building a city, they first had to solve an almost impossible engineering challenge: creating solid foundations where no solid ground existed. Their solution was brilliantly simple. Instead of searching for bedrock, they created an artificial foundation by driving millions of wooden piles deep into the lagoon floor. Most were made from oak and larch trees imported from present-day Croatia and Slovenia. The piles were hammered through the soft mud until they reached a much denser clay layer capable of supporting heavy loads. Surprisingly, these wooden piles never rotted. Because they remained completely submerged in oxygen-free mud, fungi and bacteria responsible for wood decay cannot survive. Over centuries, minerals carried by the water gradually hardened the timber through a natural mineralization process, making it incredibly durable. Even today, many of Venice's most famous buildings, including the Basilica of Santa Maria della Salute, still rest on more than 1 million wooden piles. On top of this forest of timber, builders placed thick wooden platforms followed by massive blocks of Istrian limestone, a dense, waterproof stone that resists saltwater. This layer protected the brick walls above from rising moisture, preventing salt damage that would otherwise destroy the buildings over time. Weight was another critical consideration. Unlike many European cities that relied on massive stone construction, Venice used lightweight bricks whenever possible. Buildings were carefully designed to distribute their weight evenly, while flexible lime mortar allowed walls to move slightly as the soft ground slowly settled. Iron tie rods were also installed across buildings, connecting opposite walls and preventing them from spreading apart under heavy loads. Bridges presented another extraordinary challenge. The famous Rialto Bridge, completed in 1591, was considered impossible by many architects of the time. Its enormous stone arch rests on approximately 12,000 wooden piles driven into the lagoon floor. By carefully directing the bridge's forces into its foundations, engineers created a structure that still carries thousands of visitors every day more than 4 centuries later. Fresh water posed another problem. Although Venice was surrounded by water, none of it was drinkable. The city's engineers transformed public squares into sophisticated rainwater collection systems. Rainwater flowed through stone drains into underground sand filters before collecting inside protected wells, providing clean drinking water for tens of thousands of residents long before modern plumbing existed. Even Venice's sanitation system relied on engineering rather than technology. Underground brick tunnels carried wastewater into the canals, where the natural movement of the tides flushed the city twice each day. This continuous exchange of seawater helped remove waste and reduce the spread of disease, creating one of the most advanced sanitation systems of the medieval world. More than 1,000 years later, Venice remains one of humanity's greatest engineering achievements. Built without reinforced concrete, heavy machinery, or modern geology, the city proves that ingenuity, careful planning, and a deep understanding of nature can accomplish what once seemed impossible.